Hello, everybody. This is Coach Meidenbauer from AP PreCalculus. We are going to go over sections 4.2, 4.3 because they do combine together pretty nicely. This is parametric motion and rate of change. So what we're going to do here is kind of go over some vocabulary, which is really important. And on the next page, we'll start doing some changing of variables and see how that affects our curves. So before I get started, do not forget to like and subscribe. Okay, so what we're going to do here is, before I get to this box up top here, I'm actually going to go ahead and start example 1, and I'll refer back to that box when I get to that point. So example 1, make a table of values and sketch the curve of f of t equals, you can kind of read that on the domain from -2 of t to 2, indicating the direction of your graph. And we'll do that here in a moment. Let's go ahead and rewrite this so that I have x of t is equal to t cubed minus 4t, and y of t is equal to 3t. It's going to help me out understand some of the stuff when I make this table and when I answer some of the questions to the left there. So we're going to go from -2 to -1. All I'm going to do is just plug in these values. If you don't mind, I'm just going to kind of go right through it. I'm going to plug in the -t right into the x. So that's going to give me a 0. Into the y is going to give me a -6, 3, -3, 0, 0. I do have another video on plugging in these values if you're a little lost and where this is coming from, and that would be my 4.1, 4.4 video. Okay, so I'm going to plot these points. I'm not going to connect these yet. Just got to trust me here. Okay, so I have those 5 points plotted here. I'm not going to connect the dots quite yet, and you'll see why here shortly. But if I'm looking ahead real quick, horizontal extrema, that represents the max and min values of x of t. So if I'm looking at the furthest left, furthest right, it looks like my furthest right is x equals 3, and the furthest left is x equals -3. So let's go ahead and look at this on the calculator. So let's quit out of that mode. So when you go to your calculator, if you hit mode, you can scroll down to function and change that to parametric, hit enter. And that's going to show you, if you go back to y equals, a bunch of parametric stuff in here. Okay, I already have the t's pre-typed in, but when you do hit this x button right here, which is corner from the second, it produces a t instead of an x because we are in parametric mode. So the x is function mode, the t is parametric mode, the theta is. So anyway, I typed these in. It's important you go to your window and you make sure that you have your t minimums and maximums set. I have it matching what our problem says from -2 to 2. T step, I don't really touch that. That just means how much it's going to graph within that range. So I leave the t step alone. If you hit graph, you can see what the graph looks like right here, which kind of sort of looks like what we have. Okay. If you hit trace, you can kind of see some of these values as we go through. And actually, if you're looking right here, it looks like we go to the right of 3. 3 is not our maximum, which we could not assume. But it looks like we go beyond x equals 3. So it looks like we go further right than 3, according to this, at a t value that's like -1-ish. And then let's see if that's still true as I increase my t values on the left-hand side. On the left-hand side, it looks like we're going further left than -3. So how do we find out what these maximums and minimums are? Okay, so for the maximum, for horizontal extreme, I'm coming up to this box right here. I'm going to box it for you in green. For the horizontal extrema, they're looking for max values and min values of x of t. Okay, so I'm going to actually graph x of t on the calc in function mode, because we can do more stuff in function mode than we can parametric mode. Parametric mode is really just there so you can see if you can match your graph. So let's go back here. I'm going to go to mode, change this thing back to function mode, hit enter, and hit y equals. I already typed it in. So when you do type this into function mode, it defaults with x's. I know it doesn't say t's. That's totally fine. We go to graph it, looks something like this. If I'm looking for minimum values, I'm going to hit second trace and go ahead and select a minimum, hit enter. My minimum, it looks like it's right here where my cursor is. So I want to answer these 3 questions. What's left of that? This is certainly left. Hit enter. What's right of the minimum? Hit enter. And then guess. You can just hit enter one more time. And it'll give me my minimum right there. So my minimum is that x is really my t. And the y is really my x. Sounds a little confusing here because of how the variables are. So I do have a minimum of negative 3.079. Sorry, I can't have both these on the same screen. You can just deal with it. At t equals 1.154. I think that might round. We can truncate. I truncate everything I do. Okay, so that gives us our min. And then we can go ahead and do the same thing to max. So second trace, hit 4 for max. This looks like it's an odd function, so it should be symmetric. Hit enter. We'll get the same values, except positive and negatives will be changed here. So we have a maximum of 3.79, and that happened at that t value. Again, our t's and x's are flipped, and our x's and y's are flipped as well. So max of 3.079, and this happened at t equals 1, or is this yeah, this is at -1. Okay, so on my graph here, my green graph, you know what, I'm going to change these colors up. I want to do a green graph. I'll do red. You can actually find these y values by plugging this t value back into our y. I'm not going to do that. I do know that it is slightly after right here, so it looks like I'm right there, and it is slightly before right here just by the times. So now I'm going to go ahead and connect these. Kind of sort of our graph looks like, and we are definitely going in this direction, so please do indicate the direction that we're going in. Okay. Finding the vertical extrema. So up in the box right here, vertical extrema. We're looking at maximums and minimums of y of t. So what we're going to do here is we're going to graph y of t in calc in function mode. Forgot to add the word mode up here. Okay. This one we should know. This is a line. Okay. So when I graph this just produces a line. So the maximum is going to be the last t value, and the minimum is going to be the first t value. So I can just go right ahead to here. So we're going to have a min. Oh, I want to do this in purple, actually. Minimum of -6, and that is at t equals -2. And I have a max of 6 at t equals 2. Okay. So a little bit easier on just a line. That cubic function inside of the x of t made it a little bit different. Okay, intercepts. Let's go ahead and talk about those. So we have an x-intercept when our y values are 0, which makes sense because we have no height. So we're going to take our y values, set that equal to 0. So for x-intercepts, we're going to set y of t equal to 0. So our y of t is 3t. So 3t equal to 0, and that occurs when t is 0. And I have that value right here. So we're going to have our x-intercept at 0, 0. And that's our only x-intercept. You can see that in the graph as well. Okay. Let's go different color here. So for our y-intercept, that is when our x's are 0. So we're going to set x of t equal to 0. And that is when t cubed minus 4t is equal to 0. That does factor, by the way. So I can take out a t, it becomes t squared minus 4, if you do not mind. I'm going to do t minus 2, t plus 2. A little bit of quick factoring there. When is that equal 0? When t is 0 and 2 and negative 2. In which all of those are on my table I have, which is fantastic. So I'm going to have x-intercepts at t equals negative 2. I have 0, negative 6. I have 0, 0. And 0, 6. Okay, so there's my y-intercepts. Let's talk about movement here. When is f of t moving right and left? You can see in the box right here when something's moving right. So if we're moving right, that's when x of t is increasing. That's going to be the justified portion of it. And if x of t is decreasing, we're moving left. So for part E, when am I moving right? So I'm moving right, and I'm looking for t values. So my t values are moving right, and you can just even tell from my graph. Look at the graph, look at the motion. We're going to go start at t equals negative 2 here, and that's the bottom, and we're moving right until we hit our maximum right here, which is at, and I wrote it down here in part A, which is at negative 1.154. So we are moving right t values of negative 2 until negative 1.154. And we're moving it right again from this minimum right here, which is at 1.154 all the way to 2. And why is that? Because x of t is increasing. Sorry for my poor penmanship. Left, looking again at t values. Left is everything else. I'm going left from here all the way down to here. Okay, so that is really everything else. So I'm left from negative 1.154 to 1.154. Why? Because x of t is decreasing. Okay, and you can tell that from our graph right here, going back here, if I were to graph this x cubed minus 4x. Again, you can see this graph when we're increasing and decreasing corresponds. Up and down, you can see that this function is only moving up, okay? So I'm moving up the entire time from negative 2 to 2. And that's because we have a line of 3t, which is always increasing. That's because y of t is increasing. And never moving down because y of t is never decreasing. Okay. It's going to wrap up our first question. A lot of things here. Okay, change of direction with parametrics. I got to change the notes here. There's a little bit of a typo. Oh, I can't even choose the color. There, white. Change this. They're showing, I was not white. That was gray. You just get rid of that C at the very end there. That's good to go. So for change of direction here, all you're going to do is you're just going to negate your t values, and then you got to change your bounds. So two things you got to do here. So if I am given the parametric equation of f of t, it is graphed right here. It's going to be t squared. By the way, it's going in this direction. It really should have indicated it's going in this direction. So f of t is blue, is going in that direction, and that interval from -2 to 3. We're going to verify that g of t gives the same curve, but the motion in the opposite direction. So real quick, from this, x of t is t squared minus 2t. And y of t is t squared. Oh, man. Sorry, there's a delay when I'm writing. Not that I need excuses. There we go. T squared plus t. Sorry about the poor penmanship. The delay makes it worse. It's already bad as it is. We can't have anything else happen. So for g of t, let's do red here. For g of t, if I have x of negative t, so it means I'm just going to plug in a negative t in for x. T squared still is t squared because negative t squared is t squared, but then that's going to change the sign on all of our odd degreed terms. So this is plus 2t. And then y of negative t is going to be t squared minus t. Again, the t squared, that the negative thing plugged in, it's not going to change anything. So my function now, g of t, is, oh boy, it looks really ugly. Yeah, it happens to some people. Just gotta deal with it. Is going to be t squared plus 2t, comma, t squared minus t. And then this is important. The restriction's got to change now. Now our restriction is going to be -3 because our further right restriction becomes negative and goes left. And then go to -2, +2 now. Change signs on those, okay? So now we're going this way. All right, and I can prove to you why this is doing what it's doing. So I'm going to go to Desmos real quick. And, oh, that's the last thing we just did. You can actually graph this stuff in Desmos. I'm going to do that. I'm going to do, this will be the first one, will be f of t. And then I'm going to go from, oh, wait. I'm typing in the first problem. Oopsies. Sorry for wasting your time. All right, and it'll pop up as right here. We're going to go from -2 to 3. And you can see, oh, it's not 2, it's a t. You didn't tell me. What the heck? All right. Figured it out myself. That's okay. So we have this one right here. Now, the only problem, Desmos doesn't indicate direction. I wonder if it does like a T slider. It doesn't do a T slider. It doesn't indicate direction, but if you were to plug these points in, you can see that it's clearly going to be down here where my mouse is, going all the way over here. Now, if we do the exact same thing we just did, you're going to get t squared. This is g of t now, which is going to go opposite direction. T squared plus 2t. Oh no. Comma t squared minus t. Okay. And then let's do our bounds from now -3 to 2. If you notice, the green is matching up, and you can see that the -3 part, it was the top. So now it's coming around this way to 2. And you kind of see how they are the same things. Just direction, which doesn't show that, but you can just take my word for it. Okay, last thing here is rate of change. A lot of reading here. Rate of change for parametric functions, very similar to rate of change on regular functions, Cartesian coordinate functions. All we're going to do here, and you can see this formula right here, it's rate of change. It's the change in y over change of t, all over, change in x over change of t. And that'll give us the average rate of change. Okay, so given this parametric equation right here, first things first, I'm going to first want to find out, well, x of t is 2t. Makes it a little bit easier if I have it written out. And then y of t is, I apologize for my horrible, again, I'm going to keep just using excuses. This is what my 7-year-old does. I'll be just like him. If I write slower, it works better. Make this video longer and make me look this nice. Oh well. So 9 minus t squared. Okay. So this is my parametric function already written out. I need to find out what my change of y over my change of t is, and my change of x over change of t. First things first, change of t. Ooh, that does not look at t. Right, slow. I'm going to do 0 minus negative 3. So my change of t is 3. If I do change in x, that's just going to be x of 0 minus x of negative 3. If I were to plug in a 0, I would get 0. If I were to plug in a negative 3, I would get negative 6. So that's going to give me a 6. And then delta y, change in y, is going to be y of 0 minus y of negative 3. Y of 0 is 3, actually, because we're going to get 9 minus 0 squared. So square root 9, which is 3. Minus, it's a 0. So we get 3 here. So change in y over change in t is 3 over 3, which is 1. Change in x over change in t is 6 over 3, which is 2. So my average ROC is equal to change in y over change in t, which is 1, all over change in x over change in t, which is 2. There we go. The change in t part is a little redundant because they are the same thing, but there you go. Average rate of change for the x's, average change for the y's. Y's over x's. There you go, 1/2. And do not forget to like and subscribe.